do 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 do. All right. With that said, notebooks, take them on out right now. All right. So, I'm going to try to move away from typed up notes. So, for the past few weeks, I've been giving you guys notes that have been typed up, usually on Word with some pictures and stuff like that, or everything typed up in Word. I'm going to try to move away from that and start using video. I would like to eventually have something that I could write on a screen and do stuff like that, but for the time being, I think this is what we're going to be working on. So, with that said, let's take a look over here. Learning target for today. Alright, learning target. Basically, the learning target for today is going to be using graphing techniques to solve systems of equations. So, learning target for today is using graphing techniques to solve systems of equations. Systems of equations are a very complicated. Well, okay, it's not complicated. However, I have to say, to read mathematics is a great endeavor. You should definitely pursue that. As freshmen, this is a good time for you to open up a math textbook and read through the 4 or 5 pages of the chapter and try some practice problems. Or, like I send you guys 2 or 3 pages and, try to read through those and, understand what's going on. But at the same time, I do understand that there's a need for some type of play-by-play instruction, so to speak. And that's what this video is supposed to do. So we're going to be working on systems of equations. It's a big topic of mathematics, and you're first introduced to it in algebra. Okay, so let's see. Systems of equations, let's see what they are. Okay, first off, systems of equations, basically it's going to be the use of 2 or more equations to solve for variables. Okay, so we're still solving for variables. However, we're going to be using not just one equation now, but 2 or more. For algebra, as a freshman class, we only go to 2 equations. More advanced classes will have 3 equations, 4 equations, and once you get to college, you'll have infinitely many equations. And that's usually what the realm you work on in college. Okay, so in any case, we're working on 2 or more equations. And the number of equations, this is actually an important part of mathematics. The number of equations must equal the number of variables. So let's say we had 2 equations. Well, if we have 2 equations, then we could solve for 2 variables. However, but it's actually the other way around. If we are looking for 2 variables, it is imperative that we have 2 equations. On the other hand, if let's say we have 3 variables that we want to solve for, then it's important that we have 3 equations, and so on and so forth. 4 variables, 4 equations. Okay, so the number of variables must equal the number of equations if we're going to be able to solve them. Okay, last one. Now, in order for us to do this, we need to remember what slope is and the y-intercept. So the stuff that we're going to be using to solve by graphing will be basic concept from the first first semester slope and y-intercept from this guy. Y is equal to mx plus b. Uh-oh. There we are. Okay. These are the same things that we talked about all first semester. And guess what? We talk about them in the second semester as well. All right. Today, we're going to see a few examples of this. All right, starting off. Example 1. So we're going to graph these, but before we can graph them, we need to look at these equations. All right. Notice that we have an equation on the top, and we have an equation on the bottom. Both of these need to be in the form of y is equal to mx plus b, and they are. Look at that. Y equals negative x plus 4. Y equals 1/2 x plus 1. Y equals mx plus b. So over here, our slope is actually kind of hidden. In fact, let me get a Sharpie pen for this. Our slope is 1. Our y-intercept, our b, is 4. Second equation, our slope is 1/2. Our b is 1. So let's write that up, shall we? Zoom out a little bit. Move it up a little bit. Bring it on over. Okay, so this is what we have. We have two equations, and you know what? If you want, you may as well just rewrite it. Y is equal to, we have negative 1x plus 4. Now let's turn this into a fraction. Whenever we have a whole number, we can just drop a 1 underneath it, and that turns into a fraction. Okay, we need to identify the y-intercept, our b. Well, in this case, b is equal to 4. We need to identify our slope, negative 1/1. And recall, since there's one negative sign, that could either be in the top or the bottom. Okay. So let's graph this. Our y-intercept was b, which is 4. So I put a little dot on 4. And then I use my slope. So negative 1/1. Again, remember, slope is rise over run. Well, negative 1. That means we go down 1 and over 1. Is our point. If we want another one, we can do it again. Down 1, over 1. Okay. Now, once we have that, we just connect the dots. All right, next one. Now, of course, there's going to be various types of systems of equations, whether we have solutions or not, but we'll talk about that on the next lesson. Y is equal to, what was it? Oh yeah, 1/2 x plus 1. Again, we need to identify our y-intercept, our b, where we cross that y-axis, b, and we need to know the slope for this equation, our m. So b is equal to, let's see, y equals mx plus b. B is 1. Okay, we need to find our m. Y equals m x plus b. Well, m is 1/2. Okay. So let's do that. Our y-intercept is 1. So on the 1 little dot, like so. And then our slope is 1/2. Our rise over run. Up 1/2. Look at that. Oh my goodness. They actually line up on the same, you see that? So we started here, moved up 1, went over 2. That's fantastic. And then we could do it again, up 1, over 2. And if we want, we could also do the opposite way. So just like if there's one negative sign, you could either put it in the top or the bottom. If it's positive, well, remember that's the same as if we had a negative negative. Because a negative divided by a negative is still, yeah, same as before, positive. So we could go down 1 over 2. Down 1 over 2. And then just a nice fun game of connect the dots. Always enjoy that one. Okay. There we go. We have a solution here. This is the point where both the top line and the bottom line cross one another. Now again, we will talk more about solutions and intersections and stuff like that, but you know, it's the first lesson. We may as well just jump in and see the basic stuff that we learned from first semester and how we can apply that in second semester. So solution. And we don't even have to spell it. You gotta love math. Always abbreviate stuff. The solution is, let's see, the x value is 2. The y value is, whoa, no way, really? Oh boy. That's also 2. So that means our x is 2 and our y is 2. 2 variables, 2 equations. Alright, let's try another one. Moving on. So let's take a look at these guys. Uh-oh. Oh no. There it is. Let it focus for a second. Come on, focus. You got this. I believe in you, focus. Yeah, there we go. Alright, so example 2. This one's actually going to be a little bit easier. Notice in the first one we have our y is equal to our m, negative 7/3 x plus b, which in this case is 3. Here there's no x. There's no, there's no m, there's no x. We only have our b. This case here means that our slope is 0. And these are the fun ones to the graph. So let's write them up. All right, starting off, we have y is equal to negative 7 over 3x. Y equals m, x plus b, which in this case is 3. Identify our y-intercept, the place where we cross the y-axis. Well, b is 3. Identify the slope. Well, it's negative 7 over 3. We could also rewrite that as, since there's only one negative, we could either have the choice of that negative being in the numerator or in the denominator. So, there we go. And let's graph it. B, 3. Little dot on the 3. And then over here we have our slope, negative 7 over 3 or positive 7 over 3. Now notice if we did do the positive 7 over 3, I can't do the positive 7 because I'd go up 7 over 3. But going up 7 and moving to the left 3, I'd be off the graph, and that's not going to be helpful. So it appears the first one will be the one that we'll have to use to graph this. So we go down 7. 1, 2, 3, 4, 5, 6, 7. Uh-oh. Let's do that again. So starting up at 3, the y-intercept, we go down 7. 1, 2, 3, 4, 5, 6, 7. And it's positive 3, so 1, 2, 3. Got a long stretch here. Whoa, made it. Whew. Now, a lot of you students always draw your lines half fast, and I can't do that, okay? The line should go from one side of the graph all the way to the other, just like in the other examples. You know, I don't, you know, a lot of students give up halfway. They just draw like a broken arrow or something, like a fragment of a line. Don't do that. The whole line, okay? Gotta do that whole line. Alright. Next, the second equation. We have y. Second one is y equals 4. Oh, negative 4. This one's great because notice that there is no slope. We just have a y-intercept, and our slope is 0. Alright, so negative 4. Y-intercept. That means that we put a little dot on negative 4, then we draw a line all the way across. Arrows. And our solution is right here. Solution, x value, 3. Y value, negative 4. We know our x, we know our y. And that, my friends, is that. Okay. So I'm going to leave this here for a second. Sorry about that, I did pick it up a little quick. I'm going to do 2 more examples. Alright, so the next example, we have y is equal to 7 over 2x plus 3. That's our top equation. And our bottom equation, the second equation, is y equals 1/2 x minus 3. Again, what we want to do is write up the equations in the form of y is equal to mx plus b, y equals mx plus b. Luckily they're already there, but we want to identify the m and the b. Rewrite the equation. Do that little bit of work. A little extra step. It will help you out in the long run. We have y is equal to 7 over 2x plus 3. Identify the b. That's going to be 3. And identify the m. That's going to be 7 over 2. Okay, let's just try that out. B is 3. Since b is 3, we put a dot right on 3. That's our y-intercept. Now, if I was just to do the rise over run, in this case, as 7 over 2, notice what happens. 1, 2, 3, 4, 5, 6, 7. 1, 2. Just like before. So that's not going to work for us in this case. It's a positive slope. We need to have a positive slope. Well, how else can we get a positive? It just so happens that if the top is negative and the bottom is negative, this is a key part. Top and bottom are both negative. Negative divided by negative is positive. So negative divided by negative brings us back to where we started, positive 7 over 2. So this is still a legal solution here, or sorry, a legal slope. Going to our y-intercept, let's go down 7. 1, 2, 3, 4, 5. Uh-oh. Bring this up a little bit. Start again. Lost count. 1, 2, 3, 4, 5, 6, 7. Okay, that's 7. But I also have to move 2 to the left. Negative, that's going to go in the left. Okay, so 1, 2. And now, connect the dots. Make a long line here. There we go. A little bumpy, sorry about that. And again, what a lot of students forget, you gotta extend this. It needs to stretch from one side of the graph to the other. A lot of students quitting halfway. Gotta go all the way. Put all that work in. Okay, we got our first line. Now let's cut up all the components of the second line. Y equals 1/2 x minus 3. Okay. We want to find the y-intercept, our b. We want to find our slope, our m. So what we have here is b, y equals mx plus b. Well, b is -3. Slope, 1/2. And we could also do the negative. I always like just to have both slopes because I never know. Like, maybe I use this one, maybe I use that one. I just write them both down so I have them both ready to go. Okay, y-intercept, -3. That means we're going to start at -3. So let's come on over here. -3, that's our starting point. Put a little dot there. M, 1/2. Up 1 over 2. Up 1 over 2. Up 1. Oh, okay, well, we stop there. Now, realize I want to find where this line will cross that line. So let's do the backwards one. It's, oh, sorry about that. -1, -2. Negative. Sorry about that. So slope is m equals 1/2, which equals -1 over -2. Again. Alright, so drop down 1, go to left 2. Look at that. Usually that's how it is. There's harder problems where you get fractions, but not for graphing. Usually for graphing they just like line up perfectly, which is always nice. In case, you know, in the situations where you do have solutions. Again, extend that line. Make sure you're going from one edge of the graph all the way to the other. Don't give up. We have our solution. Our solution is right there. It's kind of nice. Let's see. What's the x value? X value is -2, so let's write this down. Solution. Gotta love math. Look at that. 3 letters. Don't even have to worry about the whole word. -2, comma, let's see. Y value is -4. Alright. Okay, one more problem. Again, realize what we're doing here. We're actually just graphing one line. You graph the other one. You find their point of intersection. Again, in this week's examples, you'll always have an intersection, but that's not always going to be the case. All right, we'll talk more about that in, say, future videos. All right, last example. Now realize this is a video, so you can always pause it, but I would highly recommend that you use graph paper. Put that in your notes. Be very useful. Okay, last one. Let's first take a close look at what we have here. We have x is equal to 4, and then we have y is equal to 5 over 4x minus 1. What we would like to do is graph these two equations and see where they cross. The point at where they cross will be our solution. It'll be where basically it's the graphical way to solve for the x and y variables. Alright? This is similar to the second problem? This one here, though, is dealing with what do we got? X is equal to 4. The other one, I believe, was y is equal to -4. So remember from the first semester, when you have just y is equal to a number, it's a horizontal line. When x is equal to a number, you got a vertical line. Alright. Let's do that. We want it in the form of y. Y equals mx plus b. That's what we're looking for. First equation, x equals 4. These guys are special cases. There is no y-intercept, and there is no x. There is no slope. So what we actually have to do here is just get the x value. Well, x is equal to 4. And what this is really saying is, like, for all values of y, x will always be 4. When y is 0, x is 4. When y is 1, x is 4. When y is 2, x is 4. And even when y is 3, x is 4. When y is 4, x is 4. When y is 5, x is 4. Always going to be on the 4 for x. Can't move over here or over there. X can only equal 4. So that means our line has to go up and down. So again, just to recall, these guys are 0 slopes. Sorry. The ones with y are 0 slopes. These guys are no slopes. So slope equals no slope. And there's a nice way to write that. You can actually use the empty set. Okay. Now some people don't use the brackets. We're not in college, so don't need to worry about that. Okay, next one. Y is equal to 5 over 4x minus 1. And I do apologize if from time to time I sound a little stilted. I'm kind of like looking at two things at once here. I'm like checking out the equation, making sure I'm writing it correctly, and then I'm also looking at the camera. And so from time to time I kind of find myself slowing down my speech. But I think that's okay as well. Alright, now we're back to the original ones. B is equal to, and M is equal to. Y-intercept, slope. Okay, Y equals MX plus B. Y equals MX plus B. What's our B? Negative 1. What's our slope? 5 over 4. Alright, let's see. We have those two components. Let's plot them. B is equal to negative 1. Drop that negative 1 right there. Okay, we have negative 1 here. We put the point right there. That's our starting value. Y-intercept, starting value. Slope, 5 over 4. So that means we're going to have to go up 5. 1, 2, 3, 4, 5 over 4. 1, 2, 3. Oh boy, look at that. Points meet up. And just for posterity, we've been doing it all along. Negative 5 over negative 4. Once we have, if it's a positive, we could do plus plus or minus minus, because a positive times a positive is positive. Or, for that matter, a positive divided by a positive is positive. And a negative divided by a negative is positive. Okay? So whenever the signs are the same, and we're either multiplying or dividing, they're going to be positive. So let's drop that negative 5, down 5. 1, 2, 3, 4. Uh-oh, wait a second. 1, 2, 3, 4. Oh, we're not even going to be able to do this. We fall right off the graph. But that's okay. I mean, just splitting hairs here, I guess. If you could, do it, but if not. The most important thing, again, I can't stress this enough. A lot of times when I see students work, I say this time and time again, and kids like to align like this, from that spot to this spot, and then put arrows. The whole, the whole page, right through the whole graph. Draw your whole graph with the arrows at the edges. It just looks neater, as opposed to a half-assed line that's just like in the middle. Go that extra mile. All right. I think that's it. So, this is what's for this week's assignment. I will upload this and hopefully you guys will be able to see these and everything will work out fine. Have a good night.